All right, I hope the others are joining us, and I hope I'm interested in hearing people's thoughts on the presentation. I hope it was helpful to a certain extent. Maybe not.
Myself, Doc, I joined very late. I was held up somewhere, so I joined that presentation very late. So I missed a lot.
Well, the good thing is we were recording it, so we'll make it available. Although I guess the part that you missed out is the Q&A session, which is almost always the most interesting part. But we'll make the presentation available later today, I think.
Thank you so much.
Yeah, so Doc, hello, Doc.
Yes, hi, Euphrasia. I think Euphrasia's connection is extremely bad today. She keeps on breaking, and I see she just broke out. Okay, so I don't know if she's there. So if there are no concerns or comments, then I guess we continue with our journey, right? So today we transition to module number 7, which is not as it's not as lengthy as module number 6. And I mentioned at some point that the reason module number 6 is a bit lengthy is we tend to cover some things which were ideally supposed to have been discussed in module number 8, and so we take advantage of module number 6 to cover those things. Also, just to mention here that the other time I did manage to set up the repository, by the way. I don't know if so it turns out that because at some point, I don't know if people remember, at some point I changed the version of JDK. I don't know if you still remember these components, but it doesn't matter if you don't remember. But I changed the version of JDK, and so I needed to.
Hello.
Hi.
Because it was sure.
Yeah, I think your connection is really bad today. If you have a different connection, maybe you probably might want to switch. If you're using Zamtel, maybe try and switch to MTN. If you're using MTN, maybe try Airtel or something. Your connection is really bad today. Anyway, so I was saying that I managed to, day before yesterday we had an interaction, like that practical walkthrough, and I managed to figure out what the problem was. It turns out that the problem was I had to rebuild. I had to rebuild the software itself from scratch, which is what I did. So you notice that I have the local installation that works just fine now. So I can log in and then boom, right? So it's not as complex really. All you have to do is just follow through with the instructions really, and you should be home and dry. So you notice that all the different components are actually installed: JSP UI, XML UI. The other things that, if you remember, the other things that were in here actually. So all the applications that were built are here, right? JSP UI, OI, RDF, REST, Apache Solr, SOD, version 1, version 2, and the XML UI interface. And incidentally, lecture series number 7 includes some aspects of this software component called Apache Solr, right? It's a search platform that facilitates, it actually helps with indexing content in the repository. So it's a component that makes it possible for people to be able to search through the repository. Observe, if I go to this space and I'm just visiting it for the first time, and let's say I'm looking for information on, I guess, libraries, for instance, I'll just type in library here. What I'm effectively doing is I'm searching through the Apache Solr index, right, the index file. And you soon discover, right, after today's class and maybe perhaps after tomorrow's class, that the principles behind searching on a platform like DSpace are exactly the same as what you do when you're on the Google and you say search for University of Zambia, right? It's the same principle, right? So content on the internet is indexed by this search engine, so Google being DuckDuckGo, right? Search content is indexed by these massive search engines, and when you're searching for content on Google, for instance, what you're effectively doing is you're searching through what's called an index, right? The index will have links to actual resources. It'll be like a reference to a resource. And that resource, when you click on the link, that resource is nothing more than, it's actually located on a remote server somewhere, right? So anyway, thought I would mention that we managed to install DSpace. It's not that hard. Okay, so we immediately, as always, if you want to interrupt me, feel free to interrupt me. So we're transitioning to module number 7, which is centered around information retrieval. And essentially, we're just going to briefly walk through 3 key things. Now, there's almost always a part that involves a demonstration of sorts, right? To put to practice the things introduced, but because of the nature of the interaction, I will just provide guidelines or details where you can download Apache Sol and install it. Or perhaps we can also have a brief demonstration so that I showcase exactly how Apache Solar works. It turns out that it's not really that complicated, right? It's not that complicated. Okay. So we'll broadly look at information retrieval today, and then tomorrow and perhaps day after tomorrow, we can cover information retrieval models and evaluation, and then we'll wrap up. Okay. So unit 7.1, these are the things we're going to look at today. And so fundamental, I mean, if you're looking for, again, textbook definitions are always nice, right? So if we're looking for a textbook definition of what information retrieval is, it's nothing more than the process of searching through unstructured data or unstructured content. And you perform a search or issue a query to perform a search activity in order to satisfy some sort of information need, right? So if you find yourself on the Google, it's likely the case that maybe you already have an idea of what exactly it is you're searching for. Could be maybe a video of cats, for instance, right? Maybe dogs, or it could be literature on information retrieval, right? So you go to the search engine text field or text box, and then you type in the search query, right? What you are effectively doing is you are issuing a query based on a specific information need that you have, right? And so the searching itself is usually performed on a corpus, so a large collection of data, right? And for the most part, the data that you tend to search through is usually unstructured, right? Once you search for data, right, using a search platform, what effectively comes back, or the hits that come back, are referred to as documents, right? And so these documents, the search results that come back, will typically fall in the category of anything from web pages, books, right, news items. And by the way, some of these examples are specific to search engines, but the concept is the same, right? It could be text messages, for instance. In the case of WhatsApp, right? Search is everywhere these days. So I can come here and for some groups, right? Like I'm part of crazy groups where you have hundreds of people, and I can't keep up with what's going on there. So what I can do, same goes for the LIS group, by the way. You have people that are typing memes and whatnot, which is fine, by the way. So for me to find what I want, maybe I'll issue a search query, right? Where I'm searching through the LIS group, right? So maybe I'll search for digital libraries or something. I wonder if there's anything digital. Perhaps no. What about COVID, right? I would be surprised if there's no COVID, right? So effectively, things what comes back is what's referred to as a document, and there's a broad range of types of documents, right? So it could be text messages, it could be images, on a platform like Twitter, for instance, or forum posts. If you access a platform like our mailing list, right? So fundamentally, I can search list, which is substantially large, right? Because we've been sending through a number of messages. So for you to find what you're looking for, what you do is you use the search interface to type in a query, right? And then in summary for this particular site, what we're saying is that what tends to come back, what you're typically searching for is what we're calling a document. And the document could be anything from a web page, a book, PDF document, a Word document. Again, just to try and reinforce this idea of a collection that you'd be searching into, the example here is just showcasing a search that you'd perform on a computer, on a local computer, right? Remember, you can view your computer as being this repository of different types of information collected over time, right? Or data collected over time. Sometimes it's not always possible for you to find your way around, and what you typically do is you search for content, right? So you typically have an interface on your computer. This is my computer right now, and you would be searching through whatever it is you're looking for, right? So notice that hits that are associated with LIS 5310 in my case are here, right? Files, different files located in different directories here. Videos, Word documents, folders, PDF documents, right? Right, so you're typically searching through a collection of documents, or otherwise called a corpus, and we go through a process of defining some of these information retrieval-centric terms shortly. Right. Again, searching is broad. It could be local on a computer. It could be specific to an application, e.g. the WhatsApp application, the Google Groups application. It could be done on a fairly large scale in the case of search engines. What you're doing is you're searching through information that has been indexed, information that is contained on millions of servers around the world. And we know that there are millions of servers around the world because when you go, right, to your Google homepage and you search for a query like information retrieval, you immediately realize that the search results that will come up will be millions of results, right? These results that you get back, millions of them. Now, granted, some of these results are typically contained maybe on the same server, right? So it could be documents. It could be that that particular server has a number of documents that have the search query related, the text that is related to the search query that you issue, right? And really looking at the sheer amount of data that we are generating as a species these days, literally every application that you can think of, software application that you can think of has some sort of search integrated within it, right? So Facebook, Instagram, Twitter, your Android phone, right? When you flip over, I don't know which versions of Android you're using, but when you flip over the screen, you typically have a provision where you type in some search phrase, right? Anything, and then you get back results that are associated to the search query itself. Just wanted to mention up front here that most of what we're going to be talking about, as we're introducing these ideas, we're going to latch on to what typically happens to search engines, right? So the likes of Google and Bing. So something similar to the screen here, just because I think most of us can easily relate to this. I would be shocked if there's someone who has never searched on Google. Now, I know my mother probably hasn't. I don't know, I haven't asked, but definitely my grandmother hasn't, but don't expect that to be the case for the people involved in the cause. But even though we are mostly going to use search engines as we are explaining some of these broad concepts associated with information retrieval, just to again reiterate that some of the things that we've already discussed have aspects of search associated with them. And we know this because we introduced the idea of searching when we were talking about the second layer of digital libraries, right? The service layer. We said that a typical digital library management system or digital library system would typically have discovery services. The classic types or subcategories of discovery services are searching and browsing. You almost always have searching and browsing integrated into the average digital library management system, whether it's DSpace, there are Commons, Omeka, ePrints, Greenstone, doesn't matter, right? Islandora, search and browsing is a given, because fundamentally what you're doing with the digital library management system is you're storing digital objects, which will eventually have to be referenced or referred to or searched into by end users. Right, so screenshot of this space here where I have an interface that is similar to what you see on Google. It's become somewhat of a convention, I guess, to say if you're integrating some sort of search feature in an application like a digital library system, we typically have a search box where people type in some word character, any character they want, and then there's a button that they click, and then you get back results. Now, because of the sheer size of data that you typically have in your digital library system, in this case, or in your digital library, in this case, the user institutional repository, you typically have other nifty features that you wouldn't find on search engines, things that will allow you to fast search your results, right? So you issue your search phrase here, and then you can filter information. You can sort the information, right? In ascending order of the title, for instance. Anyway, all right. So as we are explaining, before we start looking at just brief overview of what searching is all about, now would be a good time to talk about some of the terminologies we're going to introduce. Just to mention up front that whenever we make reference to document, what we are referring to is the things that you're searching within, right? So it's usually the case that when you're searching for information, you search for information within a corpus, right? A collection of documents. In this case, it would be a digital library. Remember our definition of a digital library? It's a collection, right, of information or data. So a document is could be a file, right, within which you're searching for information or data. A term is could be loosely looked at as being a word that you will find in a document. So if we can use the slide I'm using right now as an example, this slide, this slide here, this PDF document, which has 118 slides, would be the document, right? The terms would be the things, these things that you're seeing here. These individual words would be what we're calling the terms, right? Now, again, just to remind us that we mentioned that documents could be anything from a PDF document, a Word document, an HTML document, right? A web page, for instance. But the principle is the same. You typically have terms or words within those documents. And when you're searching for content, you're actually searching for those terms. The query is a combination of terms that are associated with the user's information needs. If you go on the internet and you're about to write the exam and you're studying for the exam, for instance, maybe you find yourself typing or wanting to search for information about digital libraries. The idea around digital library would be the information need. Your need is for you to search for content about digital libraries. For you to get what you want, you typically construct a query, a well-crafted query, right? A series of terms that has different terms that are associated with what you want. So maybe it could be digital libraries, information repositories, for instance, right? So a combination of all those three words or three terms constitutes a query. Querying is the process of actually retrieving, getting the results that are associated with the query that you would have issued to this information retrieval platform. When we make reference to relevance, it's an indication of whether or not your initial information need was met. When you issue that query and you get back the result, we say that a particular result, one of the results is relevant if it is linked to your information need, right? It's not always the case that when you go online and you search for this, you say information retrieval, or if I search for, let's say I search for University of Zambia, for instance, it would be good. When I search for University of Zambia, notice that I have 171 million results, right? I don't know if you can see my screen here. 171 million results on Google, right? What Google is telling me is that the documents in the index that match this query, 171 million results. Now, it's not like all of them would be relevant to what I'm looking for, right? So perhaps this document here that is linking to Facebook places Lusaka, Zambia, this perhaps might not be related to what I want, right? So this is not relevant. Perhaps this might have information I need because it's a Wikipedia page of the University of Zambia, then it would be relevant, right? So relevance, whenever we make a reference to relevance, is an indication of whether our search criteria has been met. And then indexing is nothing more than a process of creating some file. An index is nothing more than a file within which we search for things, right? So when you're creating when you create an index, you're essentially just creating a mapping of words. A mapping of words that will be used to specify which reference has information that could be associated with the user's information need. And then ranking is nothing more than the process of ordering the results. It turns out that the average search information retrieval platform will typically rank results based on a number of different things, and it depends on the platform. So for instance, when you're searching through a search engine like Google will rank these results. These 171 million results are ranked in a certain way. According to Google, right, there's different ways of doing this internally based on the algorithm. This is more important, right? This is a much more important document that is associated with this search query. And so it is highly ranked. It is more important than the documents that you'll find on page number 10, for instance, which are pointing to this website called trover.com, right? Anyways, so just a few definitions of the terms that will typically come up. And then made mention of the fact that typically when you're searching for content, what would typically happen is you're searching through unstructured text. These documents we're talking about, PDF documents, think about this for a second. Web pages, Word documents. If you think about it, the vast majority of these categories of documents are actually unstructured, right? Unstructured because there's no implicit structure associated with them. The PDF document that is associated with an ETD would be different from a PDF document associated with slides for LIS 5310. There's no structure, right? There's no consistency in the format. Compare and contrast with certain types of data that we've looked at, like for instance, when we had our discussion of markup languages like XML, for instance, or HTML, there's usually some sort of structure, right? You have tags that have some sort of implicit or explicit meaning. HTML, title, body, right? The H tag. The same can be said for data that we store in database. There's structure there because you are essentially slotting in the data into columns, right? Remember the relational model, this idea that data that you put in the database is associated with a table. The table is made up of rows and columns, right? The columns will signify a fixed structure, right? Right, so essentially though, what we're saying is that the vast majority of searching is done on unstructured text or data. But when you index content in this space though, you actually are searching through both structured and unstructured data, right? By default, you only search through structured data because what you're searching through is doubling encoded metadata elements, titles, publisher, right? Creator, contributor. The content, the actual content associated with those elements is what you're searching through. But you can flip a certain switch in this space which allows you to index specific documents. In the event that your DSpace instance is actually storing bond digital documents, right? Or documents at least, because you can also perform optical character recognition to convert things that could have been scanned into text form, and then later on search through the text. Okay. Again, just reiterating or giving examples of structured and unstructured data here. I mentioned the fact that databases will typically have records that have a predefined structure, right? So if we're searching for content in this sort of database, we know that the the results that we get are going to conform to this rigid structure into the database. Again, this has already been mentioned. It's open-ended text. So web pages, web pages really. So PDF documents, well, actually web pages on the Google, right? These things that you're searching through. This is open-ended text for the most part. All right, I mean, again, just reiterating things that I've already mentioned, examples of instances where you might be searching through structured data, right? A database, XML documents, Markdown, right? This is all markup languages. We typically have some predefined structure, right? If you remember a discussion of markup languages, it was mentioned that typically, fundamentally, what you do with markup is you use tags to specify the structure, right? So you're combining structure with content, right? So when you're on a web page such as this one, what we're saying is that the web page itself has both the structure and the content. The content is found in between the tags. So I don't know if I can find. Let me just copy this. See if start from the body. That is much better. I guess it's inner. I'll copy out. Okay. Why this is not doing the right thing, just copy the entire element. This is a horrible example, I guess. I'll just go to unza.zm. I just want to showcase an example of some document that would have some sort of fixed structure, right? And markup languages I mentioned. So this is HTML. It's a classic example of there we go. So we were introduced to this idea of HTML tags, and we discovered that your typical HTML tag or your HTML, your web pages are composed of both. They're composed of both. Let me see if I can find content here. They're composed of both. There we go. This classic example here. They're composed of both structure and content. So if you look at this tag, for instance, the A tag specifies the structure of this content in between the tags. Right. All right. I don't have any questions so far. Is this making sense? Or am I still online? Maybe I'm gone.
Yes, Doc.
Okay, all right, thank you. All right, great. By the way, I mean, I don't know if you have slides about this, but your average application that you work with in these environments that the vast majority of you work in will typically have some sort of search interface, right? An information retrieval platform. So it could be the Coreos of YouFind of this world, OPAC, right? You're searching for content. Zachary mentioned Shepa, Romeo. What you're doing is you're searching for content, right? Content that has already been indexed. So it turns out that this whole notion of information retrieval is an extremely important aspect to look at, even more so now that we're generating massive amounts of information. Right? There's virtually no software application that doesn't have search integrated within it. Okay. And so again, just to remind us that information retrieval is loosely associated with the searching, the indexing, and retrieval of documents, right? And the retrieval process will typically place an emphasis on either efficiency or effectiveness. And we discuss efficiency and effectiveness during our discussion of evaluation, right? So fundamentally, effectiveness is loosely associated with whether or not the things that you get back once you issue a query are relevant your information needs. And there's a systematic, you see that there's a systematic process that you go through to measure whether or not what you're getting back, whether or not the platform is effective relative to what you're getting back. Now, granted, that whole process is subjective, because if you ask Lighton if the search results associated with the University of Zambia are relevant, you just ask Lighton randomly, are the results that you get back when you issue University of Zambia into Google relevant to what you want? I might say yes, they are. And of course, you wouldn't ask a yes/no question. Yes, because it's subjective. It would be like a Likert like scale type of question, where you say to what extent are the results relevant to what you want, right? So Lighton might say maybe on a scale of 1 to 5, maybe it's a 3 or a 4. Somebody else out there will say it's a 7. Well, on a scale of 1 to 5, maybe it's a 5, right? Someone will say, oh no, it's a 2, right? So we'll soon see exactly how we go about measuring these things. But take our point here is that the retrieval process places an emphasis on effectiveness and efficiency, and effectiveness is relative to whether or not what you're getting back is useful. Efficiency has to do with whether or not you're getting back the things fast enough. So imagine a situation where you go to the UNZA website and you type something and it takes 5 minutes for you to get back a result. You'd likely conclude that that process is not as efficient, right? But if you search through the Google, for instance, you'll notice that there's a reason why the Google, by the way, will also tell you to say the search took 0.63 seconds, like in this case, right? So this metric here, this 0.63 seconds, tied to efficiency, right? Anyway, but efficiency is also linked to computing resources that you might need for you to, let's say, deploy an information retrieval platform, for instance. Again, just to reiterate that the so-called World Wide Web is a classic example through the use of so-called search engines, right? It's heavily powered by search engines. Everything centered around searching on the internet, because you're dealing with large-scale information, millions or maybe billions of data, I guess. That would be nice. Maybe we can search within a search engine, total documents index by Google or something. I don't know if this search query makes sense. Total number of documents. I wonder if we can find this result here. Yeah, if you can look at this now, here's the thing about relevance. If you look at the second result here, right? We don't know the authenticity about this, but that's besides the point. This is from 2016, so you're saying Google search knows about over 130 trillion pages, right? This is a lot of data anyway. But so what we're saying is that the World Wide Web presents a classic example of searching at its best, actually, right? Because on the one hand, you're dealing with pretty large-scale data, trillions, right? And then on the other hand, you're really looking at millions, if not billions of people searching for, right? So I should change this. It's not, or maybe we should change this to trillions or 1 million works still, you know. So the size case, which is why, by the way, if you notice one of the search queries here, the search results here, when I was searching for this, if you remember, it said that, I don't know if this has to do with reaching here, the Google search engine itself, but the sheer size of the index that that Google would be dealing with here. But anyways, so your typical information retrieval task, right? As you are searching for content here, it turns out it can be viewed as being composed of certain key aspects here, right? So you have your collection of documents within which you're searching for whatever it is you want. So this collection of documents could be a collection of documents on the internet. It could be a collection of documents on a specific application, like the collection of documents in the UNZA institutional repository. It could be a collection of documents on a specialized type of application on the internet, like when you go to Google Scholar, right? You're searching through a a subspace of the internet. It's specific to this application. So content that you search for in here, search for a candle, for instance, what you get back are things that are indexed by Google Scholar, right? But fundamentally, you have a collection of documents within which you're searching for content. You have your predefined user query that is associated with the user's information need based on what the user wants. There's a query associated with the want or the need. It's a classic, the question of, that is question of what is the difference between a need or a want. We need to eat, right? But maybe we want to drink Coca-Cola. And then finally, you have a result set, right? For search engines, this is usually in the form of a so-called SERP, a search engine result page, right? This has a list of ranked documents that are relevant to the user's need. If you think about it, if you really seriously think about these different aspects of information retrieval, you realize that you can break them down based on the input that is provided to the information retrieval platform and the output that you get back. So typically the input here is the collection of documents, which is a corpus, and the user-defined query. And then what you get back is your results, right? The set of results, set of documents that match the predefined query. Again, to try and kind of visualize what we just mentioned here about the aspects of information retrieval, we typically view this in the form of this diagram here. So you typically would have some information retrieval task here, which is linked to a user's information need, right? The information need is specific to what you want from the platform, the information retrieval platform. Based on what you want, you will use certain predefined verbs, right? In this case, we can assume these are English verbs, to construct a query that matches the information needs. This query is going to be issued to a search engine or the information retrieval platform that will index a collection of documents, the corpus, right? And then once you issue that query, your search engine, based on what is in the corpus, will give you back your results. Now, almost always, when you're searching through massive amounts of information, you might optionally need to refine your query, right? So you're searching for University of Zambia, you're searching for University of Zambia, for instance. You go to the internet, the interweb, right? The internet, you say University of Zambia. You issue you get back your result here, right? You realize, oh, the results that I'm getting, these 171 million results here. By the way, the time has changed now, right? This is efficiency 0.70. Here it was somewhere it was 0.62, I suppose. But anyways, you realize that, wait a minute, these results that I'm getting back on the first page here, on the SERP, the search result page, these are not giving me what I'm looking for, right? And then you tell yourself, oh, I think what I need to do is say University of Zambia, library, and information science, right? So what you're doing here is you're refining your search query so that you get back something that is at least closer to what you want, right? So this is what we're saying here by saying you go through a process where you issue a query to the search engine, spits back the results, and then based on what you get back, you can optionally refine your query, right? So that you get back your ranked set that has things that are closely related to your need. I don't know if this is making sense. So again, I was just showcasing an example of the so-called World Wide Web, or the so-called internet. You'll find, you just go and search on the internet, right? The example I was just giving here is a classic example of what would typically happen on the World Wide Web, right? Not the internet, the World Wide Web, right? We know that the internet is composed of a slew of services, right? And we discussed all those things during our discussion of computer networks and the internet, right? We realize that it's not just the World Wide Web, so-called resources that we access using HTTP or HTTPS, but we realize that there are other protocols like FTP, SMTP, for instance, SSH, that allow us to access different types of resources on the internet. But the case the example I was giving here about, oh, I'm searching for content in a platform like Google or Bing is a classic example of what typically happens on the World Wide Web, right? And we do know now that this is $1 billion business. Who doesn't search online, right? Maybe our grandmothers, but there's a reason why we have Bing, although Google has the largest market share, but there's a reason why we have Bing, Google, very weird things like DuckDuckGo, for instance, right? There's more actually, turns out. So there are people that are constantly creating these funny, I don't know if people have used the DuckDuckGo. If you're one of those who is obsessed with security, the beauty with platform, at least this is how they market themselves, the beauty with platforms such as DuckDuckGo is that privacy, they market themselves as guaranteeing privacy of users, right? I don't have DuckDuckGo installed by default, but I have it as part of Tor. I use Tor when I'm cautious about security myself, so I'll just showcase DuckDuckGo. But it turns out that DuckDuckGo is nothing more than, it's similar to the Google. The only difference here is that unlike the Google, which meticulously keeps track of what you're doing, religiously, right? Though sometimes you can search for content incognito, DuckDuckGo allows you to, it doesn't keep in the rest of Zambia. Library information science. The bottom line here is that there are different types of search engines out there being, there's infamous Google, you have smaller versions, or not so popular platforms like DuckDuckGo, right? But the principle is the same, really. Okay. So, like we said, typically, what you get back is usually measured or evaluated based on certain key evaluation aspects, and we will mention these things that are usually linked to effectiveness. I think it's day after tomorrow where we talk about things like precision and recall and F1 scores. I won't really get into the technical details of those things, but just to highlight some important parts associated with what we are looking at here. And we'll soon see, once we start looking at effectiveness, in particular things like relevance of what you get back, that what we are looking for here is whether what we get back is linked to the subject at hand, but also in terms of efficiency, whether what we get back comes back in a timely fashion, right? In certain instances, I guess certain evaluation metrics that we might use might be linked to, I guess, authenticity of where that information is coming from, right? Anyway, user satisfaction is also something else we might talk about here. Right, and it turns out, this is, a lot of people don't realize that the things we say we search for, we're still looking at search, we're using search engines as a case here. But when we say we're searching for internet on the World Wide Web or on the internet, as they say, it turns out that what we search for is just a fraction of what is available on the World Wide Web. Why? Because what you search for is just content that is explicitly indexed. And it turns out that if you're a person, if you're a content creator, content provider, like the UNZA, for instance, you can specify, right? You can specify to say you don't want certain portions of your site to be indexed. And so those things will not, for someone who's searching on the Google for something, they will not get back hits associated with certain portions that you want to, that you don't want to index. And it gets even better, right? There are certain parts of the World Wide Web that, in fact, large portions of the World Wide Web, right? That are significantly larger than what we typically search for. So if you look at this iceberg example that is typically used here, they say estimates put what we search for at being somewhere around 5%, right? So usually when you search online on information retrieval content that is indexed on the web, they'll usually use an example of this iceberg where what you're searching for is just a fraction. This thing you see on top here, the index content, is just a fraction of what is available on the World Wide Web. It turns out that besides what is actually explicitly indexed, there's things that are part of what's called the deep web, right? This is generally content that is not indexed, but also there's a part, right? Very infamous, the so-called dark web, right? A part which is indexed, but you can only access it using specialized types of software. So your typical browser, like Google Chrome, for instance, will not allow you to gain access to the dark web, right? You need to use specialized tools like Tor, for instance, right? So in my case, for instance, I have Tor. If I'm looking for content that is on the dark web, I would have to use Tor. And in fact, the protocols that you use to access content on Tor is completely different here. Now, some of the things I'm talking about here are not really associated with the topic at hand, but I'm trying to emphasize this idea of indexing content and searching what we search for, right? And so that we gain an appreciation of some of these things we're discussing. If you're interested in finding out more about the dark web, it's quite easy. All you have to do is just download Tor. The instructions of using Tor are quite simple. Even though it's infamous for very negative things like illegal prostitution, for instance, and people selling drugs and weapons. I mean, there are stories where people say you can literally buy things like nuclear weapons on the dark web, right? And you'll never be, it's difficult for you to be traced or something. But it turns out that it can be used for good things. Like, for instance, people such as whistleblowers, for instance, who typically use platforms such as Tor to keep their identity secret. Right? So if you are one of those people who doesn't want to be tracked by the almighty Google, when you're searching on the Google, for instance, every time you're searching, you're being tracked, right? You're being tracked, which is why some of the results that you get back are related to your behavior online. So if you don't want to be tracked, what you can do is you can use platforms such as Tor, for instance, to search for content or what you want. All right, so fundamentally, really, I mean, seeing as we are using these so-called search engines or web search engines as an example, just wanted to emphasize that they're typically implemented with very interesting features, some of which you wouldn't otherwise find in your normal application like DSpace, but it's worth mentioning as we're discussing searching, right, or indexing of content, seeing as we're using search engines as a case example here. So typical platforms like Google, for instance, will have nifty features like search verticals, right, where you can selectively specify what you are actually wanting to get back as part of your search result page. So when you issue a search, you can specify on the search result page, say you want the image vertical, for instance. These verticals here, right? These are the verticals we're talking about. You can specify in the search engine, say you just want to get back images, in which case you only get back images, right? Oh, our Dean is there, right? Our Dean, okay. And then you can specify things like videos. Oh, I see, this is interesting. Our former head is also there. Tuesday, great. So verticals, right? The other nifty features like this personalization embedded within searching. So when you're searching for content, the results that you get, if I issue University of Zambia Library Information Science, so observe what happens, right? And I want to emphasize this idea of some of these things we're talking about. If I issue University of Zambia Library Information Science, if you notice the results that I get back, they could be different from somebody else who logs on from the United States and issues the same query, right? The reason being, number one, my results are personalized based on what I have searched for in the past. Why? I am logged on right now. Why else? Google knows that I'm searching right now from Lusaka in Chadley, right? So there's aspects of my location that are incorporated in whatever comes back to me. Right? So these are all really useful features that help in ensuring that the users, the user results return more relevant information based on context, obviously. So you have things like geolocation, right? Things like autocomplete features where you're typing in the search page, right? Like if I start typing university, right? You notice what's coming up? Autocomplete features. These autocomplete features could incorporate anything from what I've searched for in the past to what most people search for, where I'm located, right? So anyway, autocomplete features, and there are really other signals that are associated to this, like for instance, when you're searching once you're logged on, what the search engine will pass search history that way. Or am I online? Am I still online? Do I have to? I hope I'm not offline. I'm still online, am I not? Can you still hear
Yes,
me?
Doc.
Okay, thank you.
We can hear you.
Yeah, I always have to constantly do this because many a times I get disconnected, and so I have to constantly check if I'm online. Is this making sense though, so far?
Yes, Doc, we are following.
Okay, that's fine. So just some examples of some of the things I was talking about, like certain features associated with information retrieval linked to search engines on the internet, things like the Google, for instance. These are specific to the Google, right? Personalization based on search history. So the screenshot is just showcasing my search history, right? I always tell people that I deliberately, for research purposes and because I'm curious, what I do myself is I'm almost always logged on when I'm searching for content online. It's always nice when I visit my, is this history.search. Let me see, the link has changed, Google search. It's always interesting, my activity. It's always interesting to get a sense of what I was searching for 2 years ago, for instance. What I was searching for last year, and I don't know about you, but in fact, in most instances, my pattern is predictable, by the way. I do the same things every year, at least for the last 2.5 years now, because I'm still employed by the same employer, right? I teach more or less the same courses, or I have a few additional courses. So my search pattern is almost the same, right? And it's always interesting to look at all those things by just looking at my activity in Google search history. So I hope I don't have any, you might just find yourself showcasing people inappropriate content online, but I'll just go to the ones right here. That was a joke, but you can notice here that there's a search history that comes from all different Google services like YouTube and Google search and all these different funny places, right? And in fact, if you think about this, right, this is precisely how these giants, right, these search giants like Google and Microsoft make their money, right? They sell you ads. When you're searching for content, you log in online and let's say you say University of South Africa, I suppose. University of South Africa, UNISA. What you notice is that in certain instances, right, and this is a bad example, let's say University of University, okay, Stanford University. I want to showcase something. Bad example as well. Let's say building materials. And there's something I want to showcase to you, and it's not working. I'm not sure why. But you notice that in certain instances, when you issue a query, okay, let me say tablet computer prices. I'm trying to showcase something here. Why is this happening to me today? I don't know why. But I don't know if you've noticed that in certain instances, oh, there we go. Maybe because I'm logged on. and because I've configured my account in a certain way. I don't know if you've noticed that when you search for content on the web, right, you typically see things like AD. This is an ad, right? So this is how these entities make money, by selling ads. So there are companies out there that want to be ranked on top. They'll pay extra money so that they are ranked on top, even though you did not search, even though this might not be related to your search result, but because these entities are paid money, these things will pop up, right? So this is how these entities make money. And I'm talking about this because of your search history, these ads will come up based on your behavior. The search ads that I see when I issue certain queries in my account are based on my past history and what I search for actually. In certain instances, even applications that I'm accessing, right? I don't know if you've noticed this, but that sometimes when you're searching for certain content on Google, you realize that when you're on Facebook, some ads on Facebook will be based on your search, right? History in Google. Anyways, I thought I'd mention that, but it's neither here nor there. So features like personalization, this is what I was talking about. Autocomplete, really classic here, where you don't have to completely finish your search query, right? There'll be an autocomplete feature, and then based on what other people searched for in the past, you have the list of options that come up, and then you realize, oh, when I'm searching for how much does X cost in Zambia, maybe Google thinks I'm searching for how much bride price is in Zambia. This is a new one. It's become expensive now, apparently, which is quite sad. Or how much of toffees, right? I didn't know that people are searching for IVF cost in Zambia. But all nifty features associated with search engines here. And I always like using this example. I do encourage you to go here, by the way. It's a platform called a web search engine called Fixer.com. They published an article a while back where they did some really superficial study based on the autocomplete feature of searching, right, in search engines like Google, for instance. And what they came up with was things that people around the world, in different parts of the world, typically search for. And they were able to do that, just pasted the query there. They were able to do that by taking advantage of the autocomplete feature, right? I hope it's still up and running. I think it is. It's a really interesting thing here. You notice that, I don't know how far back this was done, but you can literally see that interesting things like, at least the time this was done, apparently people in Zambia obsess a lot about how much a wedding costs, right? In Namibia, it's how much petrol costs. In South Africa, it's a cow. Most of East Africa, it's a cow, right? Now, even though this has little to do with what we're talking about, we're just talking about search engine features here. I always think it's interesting, right, to look at some of these things, what you can do with these search platforms, information retrieval platforms. It's quite nice. I guess using that, you can kind of like deduce certain things linked with societal behaviors, right? Value systems in different parts of the world. Like, why would people be searching for kidneys in this part of the world, right? Or why is it that a lot of people in this part of the world are talking about electronics? This is China, right? Beer in certain parts, prostitution. Oh, wow, this is a new one. I didn't know. Now, it says a lot about what people that are searching online value, right? IVF in Australia. But anyways, this is interesting. We always have fun looking at this when we're discussing. I always have this in slides or when I'm talking about this. And really interesting that in Congo, people would much rather search for how much it costs to build a house than in Zambia, where people are searching for how much it costs for a wedding. Nothing wrong in searching for how much it costs to, I guess, do a wedding. I'd like to think it's expensive. I remember a friend of mine getting married many years ago. They went to Pamosi and it cost him his arm, I guess. But interesting things, all because of these features, autocomplete features, but also interesting things like certain different ways of accessing information on the search result page. So-called search verticals have become tremendously important, right? So you can specify what sort of documents you want. Remember, I mentioned when you're searching through a corpus of documents. You can decide to say you want to filter just images, videos, or news items. right? All interesting things. And really, if you pause and think about this, you realize that search engines have evolved over time, right? You now have knowledge cards that you typically find in information, search engines, right? So if you search for, I hope I have a knowledge card myself. The people that generate content on knowledge, I don't have a knowledge card. Wow. You typically, I wonder who has a knowledge card. I've lost my connection. I think you should be still there, right? So knowledge cards, right? So when you're searching for specific types of people, you have easy access to certain information that you would otherwise have to access by clicking on a link. I thought I had a knowledge card. Wow. Guess I'm not generating enough information now, am I? Why I don't have a knowledge card. Maybe I am, maybe I don't. Unfortunate. Knowledge card. Last time I checked, I did have a knowledge card. Anyway, that's besides the point. My ego has been broken now. I thought I did have a knowledge card. Anyway, but you find these things, right? Like our able leader, right? His Excellency Edgar Kagwarungu, right? Probably has a knowledge card because it's an important entity, right? So, and usually these knowledge cards will typically be pulled from collaborative platforms like wiki platforms, right? So this is probably coming from Wikipedia or something, right? Source, Wikipedia. Pausing to see if we're there, I suppose. Yeah, it's quite sad when your search result is linked to Lungu denies financing on these variables. But of course, when you're a politician, this is what happens, right? It's quite sad. Okay, life is sad. The certain interesting features that you find is things like you being able to filter a specific point in time where you want to search for content. So when content was published, based on where that content is coming from, which part of the world, like the country, right? In the past, there were even signals that allowed you to search for things that you had already searched for. Anyway, so I hope I don't know. That was a kind of like a swift introduction to 7.1, which is just an introduction to information retrieval. I don't know if people have specific questions. I was hoping we could proceed to 7.2, but I think we can proceed actually. That would be nice. Yeah, we can proceed. Are there any questions with regards to what we're talking about in 1? I don't know if people have specific questions with what we've looked at so far. Just say the fundamentals, really, concepts, basic concepts are associated with information retrieval. We're setting the stage for our discussion of, we're trying to better understand exactly how these information retrieval platforms work. And it turns out that it's important for us to evaluate how effective they are, especially. Do they do what we want them to do? And this becomes tremendously important if you ever find yourself in a situation where you create a web portal, similar to what the UNZA has set up, for instance. It's a bad example, but this is a classic kind of a scenario where you might want to seriously think about this. If you have a platform like this, right, on the UNZA website, where there's a section that's linked to the library that has different e-services, you want to have an integrated search feature where you type in a phrase, and the searching involves checking all the different platforms that you have as an organization. And then the results that you're getting back will be taking you to those different platforms. And you saw this, right? If you remember when I don't know if it was Cornell University Library. Is it Cornell or Penn State? Maybe it's Cornell. If you go to these like integrated platforms that are used by most libraries, you typically have a search platform here. When you search in here, right? If I just search, I don't know, I can't think of anything to search for, maybe cases. What you will notice is that the results that come back here are supposed to be results that will take you to different parts, different types of systems, right? And you can easily check this by looking at the URLs as you're hovering over this. No, this is all the same. Yeah, so you notice this result is coming from the repository. If you look at this link here, observe. If I paste this link and I compare it to what is coming from these digital collections, what you will notice is that these results are coming from different servers or applications. But the search, the integrated search interface is implemented in such a way that searching is done on all platforms that are associated with, I guess this is like the library entity for Cornell University, right? So it becomes important when you're wanting to implement such a feature to evaluate the effectiveness, right? Whether or not people will be able to get what they're looking for. Does this make sense? Can we proceed to 7.2 unless if people have questions?
Doc.
Oh, yes.
Hello,
hi.
Doc. Yes.
Yes, hi.
I think I just missed something on the IRA terminologies. You mentioned of the document,
Yes.
the query, the querying, relevance, and the other two. I think I missed them.
Ranking and so I mean one way of looking at and something that's missing here, by the way, is the corpus. The corpus is a collection of documents, within which you're searching into, right?
Yes.
I don't know which one of these was not very clear. So
I think
there's a corpus. There's supposed to be corpus here. The corpus, so for instance, if you look at the Unza institution repository, sorry? I'll pause and wait for her.
Sorry, Doc. I'm listening.
To ask, I think I'm cutting off. Couldn't make out who was talking. Was that?
Hello?
If someone could, yes, hi, okay.
Yes, I'm listening.
Right, so what was your question again? I couldn't get what your question was.
I was saying it's like I missed one or two terminologies on the IRA. I remember document, query, querying, and relevance. The other two, I think, I didn't get them too well. And the mention of corpus. I submit.
Hello, I can't hear anything. Is everyone able to hear the dog?
I was muted. I do apologize. Sorry. Yeah, I was muted. Thank you. I do apologize for that. So I was saying that the terminologies, the reason we're talking about this is because once we look at evaluation, these things will come up again, right? But it turns out that you can understand this by looking at a specific case, either using a search engine like Google or using the UNZA institutional repository in this case. So if we use DSpace is composed of a corpus, which is a collection of all the documents in DSpace at UNZA. The corpus has so far 5,829 documents. The documents would be the individual objects. It's 5,829, right? So these things here, the metadata, including the bitstream, these would be the documents, right? So we have 5,829 documents. The terms would be the words that we find either in the metadata, so these terms here, or if this DSpace instance has been set up in such a way that you can open search has been activated where the actual documents are indexed, the content in the documents are indexed, then the terms will also include the content in the PDF document, right? The query is a set of terms that the user like Lighton will come up with to search what they want. So if Lighton wants to search for information science, when I write information science, this information science is the query. The querying is a process of retrieving information down from when I click the search button and I get back. This is a querying process. I'm querying for this information science. Relevance is just an indication of whether, it's a criteria that indicates whether what I get back is related to what I want. This is subjective, obviously. Indexing is a behind the scenes, for the case of this space, behind the scene process. It's a service actually incorporated within DSpace that allows you to associate terms in the document to facilitate searching. So when I say information science, when I write information science, what I am doing actually is I'm not searching these individual documents. I'm searching a predefined index. It's been built, right? There's an I hope Solar, please. Maybe our subject repository might have a search archive. Okay, I want to showcase something, to showcase to you that, anyway, we will do this during the practical. But the indexing process is a process, it's a service incorporated with the average digital library management system that makes it possible for you to create an entry of terms associated with that document when you go through that submission process. So in this case, when you ingest or you deposit an object, behind the scenes, there's an index that is created, right? And the index will look, which is page number, I don't know where we are, but I'll go back, page number 10, I suppose, I don't know. But your index will, I don't know if we'll be able to get this, but it will be some, I hope it's there, but it will, there we go. So in this space, you have access to, there's an Apache Solr application, I mentioned this. So what you do actually when you're searching is you're searching through a file that has these predefined terms. In fact, the same thing happens on your, I think there's Baloo here, Baloo CTL. On your average application, there are indices that are created. So in my case, I mean, Baloo CTL. So I can check for certain words, right? Certain words in the index associated with my operating system. When I'm searching, I'm not actually doing a brute force search to search all the millions of documents that I have on my computer. That would be insane because it would be inefficient. Instead, what happens is every time I create documents, I copy documents on my computer, there's an index file that is updated so that when I am using these features and I'm searching for LIS 5310, I'm searching through the index here. That index has entries of these documents. Observe, You notice this document that is LIS 5310-2. If I click on this, I open the document, right? Yeah, but observe what happens. If I go to this download folder and I delete LIS 5310, this, wow, LIS 5310, and I think it's 2 or something. Come on, really? Okay, let me just check this document here, this LIS 5310 document. You notice this document? I'll just need to do something. I'll do save as, and then I'll copy this file. I'll close this, and then I will go to my downloads folder. Yeah? And then I'll try and see if I can, I'll arrange this by name, and I'll try and see if I can go to LIS 5310. You notice that the document I just opened was, where is that document? It's this document, yeah? Observe, I'm going to delete this document, right? I'm deleting this document, I'll say delete. When I come back here and search, that document is not there. Notice when I searched LIS 5310, and I think the indexing was done on the, oh my goodness, oh, it's here. It's this document, right? Because I've deleted it, it's supposed to be in downloads. If I open this, it's not there. The reason I can see it here is because I've deleted this, but the reason I can see it here is because when I'm searching, what I'm doing is I'm searching through the index. So obviously I'd have to wait until the index is updated to reflect the fact that that document is no longer there, which is why I'm getting an error now. Right, so that's the whole point with, I guess, the index. We're talking about the terminologies. That would be the process of indexing. Whenever you create a document, your index is updated. This happens everywhere. On the Google, for instance, Google will typically say, I don't know if you people follow through with what happens on Google Scholar, for instance. What you will realize on Google Scholar is that every time they will normally tell you to say they've refreshed the metrics. You see this? It's saying the new 20 metrics are released per se, but the concept is the same. It's in the index, right? Because maybe as part of the reindexing process, I guess there's no indication that entry no longer exists. Then ranking is just nothing more than ordering the results really, in such a way that indicative of the importance of the result set based on what sort of query is issued by the user. And this is subjective really. What is relevant to you might not be relevant to me, right? Which is why it's subjective. And you soon see the techniques that I use to evaluate platforms like that. Are there any other questions? Before you just briefly, I think we can cover 7.2. I think I prefer we cover this because we can cover this and then finish tomorrow so that we give Abel a chance to do his talk on Friday and then maybe start module 8 actually on Friday. That would be nice, and maybe Saturday or something. Are there any other questions?